This morning we're going to take a look at this PhET Charges and Fields Interactive Lab. You're going to need a few things for this. First of all, obviously, you're going to need the simulation. You're going to need a copy of the lab handout. Now, normally I wouldn't mind if you printed one out and then wrote on it and just took a picture or scanned it, but this one, it really is going to be easier in the long run if you try and do it in the Google Doc, because there's going to be an awful lot of screenshotting and pasting in of screenshots and stuff we're going to need to do. And you're also going to need your Graphical Analysis app eventually. So you want to be sure that you've got your Chromebook and you've got that so that you can put in some numbers. We're going to start by opening up the sim. And you can see once you step in here that you've got a box full of controls on the side here. You've got a couple different tools that you can drag out and mess around with. One is a voltmeter, and one is a ruler. And then at the bottom here you've got positive charges, negative charges, and also sensors that you can drag up into the grid and play around with. We're going to see what they want us to do here. Start by inserting one positive charge at the center of our screen, and then we're going to check the box marked values. Okay, I'm going to check that. I'm going to check values. Okay, there's a positive charge there. Drag a sensor and a ruler on your screen, and then measure the distance between the charge and the sensor by placing one end of the ruler at the center of the charge and the other end at the center of the sensor. So I'm going to grab a sensor and just drop it out here somewhere. Okay. And I'm going to measure the distance. I've got two little crosses on the ruler here. I'm going to put one right in the middle of my charge and one right in the middle of my sensor. And, okay, let's see where I need to record that. It says to record the distance and the field strength in data table 1. So we'll come on down here. So field strength we're going to read as 5.81 volts per meter. So I'm going to type in 5.81. And obviously if you've got yours in a different place, you're going to have a different set of numbers than mine. My distance is 124.4 centimeters, so I'm going to type in 124.4. And it says repeat step 2 and 5 for at least 5 different positions in the range between 20 centimeters and 400. So move the sensor, measure the distance, record the data, and repeat. So I need to do that 5 more times. So let's move the sensor about here. Let's see if I got that too far or not. That's just fine. Okay, so I have 1.27 at 265.5. And so on and so forth. Let's get one that's really close. Okay. So 15.9 at 74.5. Now if I was concerned at all in looking at what the trend is, then I would be more systematic about it. I might start close and then gradually work my way out so I could see a trend right on the data table. But we're going to end up graphing these, and so it really doesn't matter what order I do them in. I'm going to take this and drag it way out here. That's still within my 400 limit, so I've got 0.72 and 353.5. Let's do just a couple more here. Okay, 120 on the dot, so 6.19 at 120. even though I don't have these in any kind of order, I can already tell that the closer I am, the less distance, the stronger the field strength seems to be. So let's get one more. Let's do one really close. I think I can get closer than that. Let's try. Yeah, great. So 145 at 24.5. All right. Let's move on and see what they want us to do with this. Okay, we're going to open up our Graphical Analysis app. We're going to select Manual Entry. We're going to plot a graph of field strength E versus distance. So my field strength is going to be my measured variable, so I'm going to put the distances that I was picking out on my X. So let me drag this guy over here now. I'm going to go into Manual Entry. Let's see if I can scrunch this down enough to where I can actually see both at the same time. Maybe if I move my big fat head out of the way. Okay. All right, so for X, I'm going to do 124.4, 265.5, 74.5, 353.5, 120, and 24.5. Let's come back up here and do my Y. Okay, so now let's enter in our values for Y. So 5.81, 1.27, 15.9, 0.72, 6.19, and 145. Okay, now I've got my numbers in here. I'm going to take a look at my graph. I'm going to fill up my window a little bit. And it almost looks like, definitely looks like I've got some kind of a curve here. So let me see. My directions now want me to apply a curve fit and find one that best fits my data points. So I'm going to play around with curve fits here. Linear is definitely not it. Not quadratic. Power? Wow, look at that. Look at that. Oh, that's sensational. Look at the fit right there. Okay, so I'm going to go ahead and guess that it's a power curve. So my formula here is y equals ax to the b. Let's see what they want me to do here. Select and apply a curve fit that best fits your data points. Be sure the equation and variables of your curve fit are visible. Insert an image of your graph below it. Graph 1, E versus D. Now, as far as taking screenshots, if you're using a Chromebook, I did a little bit of hunting around and I found out that you can hit Control Shift and your change window button, and it'll open up a little thing where you can draw and you can take a screenshot of a portion of your screen. And so you can use that to just grab, a chunk of your screen with your numbers on it. I'm going to do something similar to that. I've got a thing, since I'm running Windows, it's a little snipping app, snipping tool. Start a new snip. Probably crash my poor computer here doing all this garbage. Actually, before I do that, I need to check and see. Okay, I do need to put some labels on my graph before I do all that. So I need to label the axis names. Okay, so we're going to come in here to edit graph options. So my title is going to be distance versus field strength. So that gives me that. You know what? I think what I can do is I can go ahead and just put the label here in. I'm going to go distance x versus field strength y. It's a way to cheat. That's okay. So I'm going to hit enter on that. Now I'm going to take my little snipping tool, snip myself a picture that has my graph and my numbers in it. And looks like part of my camera window there. And I'm just going to, if you do it on a Chromebook, it's going to save it as an image in your screenshots. I'm going to just click copy on mine here. I'm going to come down to where it says insert your graph image here. I'm going to highlight that and I'm going to hit paste or Control V. Of course, it's going to be way too big, so I'm going to scale it down a little bit. Make sure I can make it fit. Why is there such a massive space underneath here? Oh, probably because I put in a massive space underneath here. Okay. Now it wants me to start a new file or add a new data set, and it wants me to plot a graph of electric field strength E versus 1 over d squared. So I guess what I need to do is I need to come in here and I need to calculate what 1 over d squared is going to be on all of these. I'm sure that there's a way that I can make the computer do that for me, but I'm not going to stop and figure that out right now. I'm just going to do 1 divided by 124.4 squared on my calculator. And I'm going to get 6.46 times 10 to the negative 5. Let's do the same thing on this next one here. 1 divided by 265.5 squared. You get 1.42 times 10 to the negative 5. Divided by 74.5 squared. I get 1.80 times 10 to the minus 4. Divided by 353.5 squared. 1 times 10 to the minus 6. Divided by 120 squared. 6.94 times 10 to the minus 5. And 1 divided by 24.5 squared. 1.67 times 10 to the minus 3. Okay, so I'm going to see if my graphing program will let me just add a new data set to what I already have here. Sure it will. Okay, I need to leave my y alone. My y data set is going to be the same. So let me copy all of this into my y. It's my x's that are going to be the new number. So let's put all of those in here. So 6.46 e negative 5 Let's try where it will let me type 6.46 E. Okay. 1.42 E -5. 1.8 E -4. Okay. 8 E -6. 6.94 E -5. And 1.67 E -3. That gives us quite a different picture. Oh, look at that. Look at those data points. So let's try and do a curve fit to this. I think, yeah, I'm 99.9% sure that linear is going to be what we want to go with right there. That makes more sense. Thank goodness. So let's come in here to our graph options. We're going to change this to 1 over distance squared. Versus field strength Y. I'm going to take another screenshot. Showing my numbers and my equation right there. I'm going to go paste this into my paper. So where it says insert your graph image here, go V. Shrink it down quite a bit. Yeah, I'm liking that a lot better. So now I've got an entirely blank page of lab. I think I can probably delete on. There we go. All right, so at that point, I can start my analysis on part 1. I'm going to leave that for you to do, and we're going to take a quick look at part 2, which is where we map electric fields. So I'm going to go back to my sim, I'm going to hit reset, and I'm going to check the boxes for electric field and grid. So electric field is checked. I'm going to check grid. On the box bottom, drag a red 1 nanocoulomb charge in the middle of the screen. Note the arrows that appear, okay? And then try dragging the red charge around and see what happens. And then I'm going to make some observations. So I'm going to put this guy on here. Okay. So a few things I'm observing is that arrows seem to point away from the red charge. Oh, that's cool. As I move the red charge around, the arrows reorient themselves. And it also looks like the ones that are closer to the red charge are bolder, and they tend to fade out the farther away you get. So if I was going to come in here and make some observations, go ahead and do it right here. I'm going to go ahead and maybe pick a different color so that I know that it's me that's typed this in and not the paper itself. So I'm going to say something like arrows lead away from the charge. They shift as the charge moves. They are darker the closer you get to the charge. Something like that. Okay, and then drag all charges back to the box. Repeat step 2 with negative charges. I'm not going to spoil that one for you. I'm going to let you play around with that. What kind of charge seems to be a source of E field lines, meaning that E field lines, we learned in the thing yesterday, are these arrows. And so if I was to say what kind of charge is a source of E field lines, it looks like they're coming from this red one. So I'm going to say in this blank right here, probably positive charges. Cherbies? Sure. I'm just going to guess that the negative ones are going to be the opposite of that, but rather than guess, I'll let you play around with that and see what you discover. But I can put a little more space on my page here. Yeah, okay. All right, reset the sim, check electric field and grid. Oh, now you're really going to like this part. Drag one negative charge to an intersection of heavy grid lines. So I'll drag a negative one out, and I've got some that are heavier, some that are lighter. Over toward my left-hand side, it said. Okay. It says, move the crosshairs of the voltmeter to the next heavy grid line to the right, record the equipotential and volts on data table 2, and then click the pencil button on the meter. So I'm going to be filling some stuff in down here. So I'm going to drag this out here. I'm going to put the crosshairs on the next intersection of dark lines. Looks like it's going to be right there. It's going to give me an equipotential of negative 18.46. So I'm going to put that in right here. Negative 18.46. And it says for me to click the pencil button on the probe. Oh, it puts down a little green line. I'm going to come out here to my next node away from that. It gives me an equipotential of negative 9.056. Negative 9.056. And come in here and click pencil. Again, that's curious. I'm not going to do all of these. I'll leave the next few for you to do. And then on number 10, it says to take a screen capture of your final pattern, insert it to the right of data table 2. I don't want to skip step 9, but I'm going to right now because I don't want to spoil it for you. But after I finish doing this, I'm going to take a screen cap of what I've got right here, and I'm just going to go ahead and do it now, even though it's not complete. New screen capture. Copy that. And then if you look here in the table, I've got insert your screenshot here. So I'm going to paste that in there. I didn't break things too bad. See if it will let me resize that. It will. Oh, nice. So I can actually make it fit. Okay. And then from here on out, you're going to be doing similar to what we've already done. You're going to reset. You're going to put the charges out there where it tells you to put the charges out there. I'll go ahead and show you number 11. Electric field and grid. Wants us to put a red nanocoulomb charge on the left and a blue one on the right, 200 centimeters away. So put a red on the left, put a blue on the right, 1, 2. I think that's 200, and I can verify that with my ruler here. Yeah. So you want to get them where they're 200 centimeters apart, so that's going to be 1, 2, 3, 4 major nodes apart. And then you're going to follow the directions from there, answer the questions as you go. And that's really all there is to the lab. I'm going to go ahead and stop the recording. Then if you've got any questions, you are more than welcome to ask them. But anybody who's watching this later on, I'll try and clean up some of my mistakes so you can maybe not have to sit through all that. And best of luck.